You are in Module 19. Well, so am I. Let's get started in Module 19 and look at cloud computing. In Module 19, we have a lot to talk about because cloud is one of the fastest growing, exploding technologies out there. Actually, cloud is a collection of thousands of technologies that we're going to talk about, just some of the big ones as we go through this class. So we're going to look at some of the basic concepts, and we're going to move into some of the threats and the methodology for hacking cloud computing. Then we're going to divide it out to some of the biggest vendors, including AWS from Amazon, Azure from Microsoft, and the GPC, the Google Cloud, from, well, Alphabet. And then we'll look at containers. Then we'll spend a lot of time going through cloud security. So that's what we have up for this module. Let's get it started. Here in objective number 1, let's just look at some basic concepts of cloud computing. So for the first set of concepts we want to look at is the types of service. What we look at is this whole idea of as a service. So platform as a service, container as a service, infrastructure as a service. Hey, another really cool Wikipedia article is you type in Wikipedia and then as a service, and there are just dozens and dozens of these as a service definitions. So when we're looking at infrastructure as a service, we're looking at things like EC2 or OneDrive or Rackspace. We're looking at maybe virtual machines, disk storage, stuff like that. Sysadmins might use that. We're looking at platform as a service. We're looking, it used to be just stuff as simple as IIS or some other type of web server, but now it's Azure itself and Salesforce itself. It's a developer platform. And then end customers would use software as a service. You're using software as a service when you take the labs in this class, or when you use Google Docs, FreshBooks, or you use that nice Google Calendar or Microsoft Word online. Sysadmins might want to use identity as a service. Microsoft Azure has their Intra ID, which used to be called Azure Active Directory, Okta, and many others. If you are a developer, just like over here, you also might want to use security as a service to lock down that app that you're writing with eSentire MDR or SwitchFast or some of these other technologies. An end customer like me or you might use container as a service. In fact, if you're using software as a service, it's very likely that that software is containerized. So we might also use Lambda. We'll talk more about function as a service, where we can take our app and offload some of the functionality into the cloud. And then end customers might use stuff like AWS, Google Compute Engine, Azure O365. I've used so many of these. I've hooked up my customers with many of these products, and there's more. If you can consider it, it's probably as a service somewhere. One of the things you want to realize and keep in your mind about the cloud is that the responsibility is, what's that word on the far left corner over there? Shared. Hey, I heard you say that. That's good. Shared responsibility. And as a shared responsibility, unlike on-prem, when you walk into your data center and it's all yours, all the way from the application down to the networking. You could pull up the tiles in the data center and all that cabling is yours. I remember I got hired at a spot to help manage their data center, and their cabling just looked like a Brillo pad. It was just like dense tangles. And I had my network administrators just take shears one weekend, and we cut all the cables with shears, and then we remapped everything one at a time. Oh yeah, that networking was ours. But over here in cloud computing, if you're running software as a service, what do you control? Nothing. Nothing. It's all the provider. whereas you still control OS, middleware, runtime, etc. if you're running infrastructure as a service, like if you spin up a VM in Azure or something like that. So let's talk a little bit about fog. Reminds me of a ship's foghorn when I say that right now. So fog computing, the fog's rolling in. Where's the fog rolling into? It's rolling very close to the edge. And what's the edge doing? Well, the edge, one of its main purposes is to distribute processing. But also the edge is close to the devices and controls that need it. Think of this. There is a automated car. The automated car is driving around the streets of some California city, picking up people and taking them places. And this automated car, you've seen some of them with the cameras and stuff on, they're using LiDAR and stuff like that. And they're picking up people, these little robo-taxis. And they need to communicate with other resources. But the latency of a decision that needs to be sent all the way up to some workflow in AWS, that latency is actually lethal. You can get in a traffic accident and kill a driver or something if you have to think that much. So what they do is they cache all the caching, optimization, machine to machine, real-time data processing is at the edge. And then we give those edge devices and the end devices a little bit more power with servers, fog nodes, where we can do some pre-computing. This also helps to take the computational load and make it so it's more efficient going to the cloud and back. So with cloud, fog, and edge, this really helps with a modern economy where you have everything from robot arms to humanoid robots, robo-taxis, Tesla cars driving around, no one in them, picking up people, and so on. What is a container? Speaking of AI, there is a very interesting, and speaking of containers in AI, there's a very interesting test that you can do to see how smart your large language model is. And essentially the prompt that you put in is, there is a marble in a glass with an open top. The glass is turned upside down, and then the glass is put in a microwave oven. Where is the marble, or something like that? And a lot of them think that the marble is now at the bottom of the glass, thinking of containers and AI. And in this case, we're not talking about a container with a marble in it for a large language model to stumble over. Matthew Berman, he's the one who does that. If you look up his YouTube channel, very fascinating stuff. But either way, what we do in this case is we have a container. The container is a way of allowing an application to run with the least amount of resources possible, very leanly, if I can use leanly as a word. So what happened previous to containers, the previous technical revolution was virtualization. And so back around the turn of the century, there was a revolution in virtualization where literally data centers would shrink by 90% because we virtualized everything. And then you could have a virtual machine, and that virtual machine would have, let's say I had one piece of software on that virtual machine. I've done this before. And so like it's a DHCP server or a DNS server. So let's say you're running a DNS, you're running bind on a VM. So even if you install it with the smallest footprint that you can with the operating system, still you have a vast array of binaries and libraries that are just not being used because you're just running one app in that virtual machine. Now, picture a scene where you have an application, and the application, let's say it's still bind for DNS, and it's saying, you know what, I need these 3 or 6 or 10 libraries and these binaries in order for myself to run. Instead of having hundreds of them, you just put in a few. And so now this containerized application with these only the microservices that it needs, instead of the entire array of services on the operating system, now we can, instead of running, let's say, 100 virtual machines, I can run 1,000 containers. So you've had experience with containers. You know why? Because if you've used software as a service, vast majority of those are containerized. So you've seen the end product of that. So what happens with containers is you have hosts. That's like a physical computer. Your laptop, your desktop, you can actually run containers. I don't care if you're running on a Mac or a Windows box or a Linux box, you can host containers. And then what we have is administrators that help with container registry and internally and externally. There are repositories. And we have developers that test and accredit them, create images for these containers, etc. And then over here, in between everything, we have an orchestrator. And I just want to introduce the term orchestrator because we haven't really talked about orchestration in this class yet. My definition for orchestration is heterogeneous optimization and automation, especially automation. Heterogeneous meaning different stuff. Let's go back to the root of orchestration. An orchestra. Have you ever been to a live orchestra? I don't care if you love like hard, loud music. One day you should go to your town's live orchestra and check it out. So what happens is you have a stage that's full of instruments from violins to viola to percussion and many other things. And then standing in front of it is a conductor. What happens with an orchestra in an auditorium like that is we have a lot of heterogeneous controls, inputs. These are different instruments. They're different clefs. They're different sounds and so on. And every one of them has a programmatic sheet in front of them, which is a way of both going procedurally, looping, etc. That's what sheet music is all about. And they're following that, but they all have to follow at the same time. And certain things need to be emphasized and non-emphasized, quieter and louder, and so on. And so what the conductor does is orchestrates those heterogeneous inputs to follow that programmatic action and produce that beautiful music. That's what we're doing here, although the music is the flow and control of all these tens of thousands, millions, in some cases billions of heterogeneous elements. And so when I say, hey, you know what? I want these types of elements to go and grab their updates, then they can all do that with an orchestrator. The main orchestrator we're going to feature in this module is Kubernetes. So Docker is the main tool, the literal inventor for the most part of containerization. And so with Docker, it's open source. Google invented it before they became Alphabet. And it gives you that platform as a service capability. The core of Docker is the daemon, the Docker daemon. And what this is the service. It runs in the background, coordinates everything between the images and the containers. It does pull requests from a Docker registry, and then on this host is where this Docker daemon is running. The client can do Docker builds and Docker pulls and Docker runs. These are ways of working with Docker containers. And then we have the container images themselves and volumes and networking that happens between the containers. There's all kinds of networking and managing those to the Docker CLI, the command line interface, allowing RESTful API connection and programming and so on, and that server Docker daemon. So Docker is the major tool. There are lots of others out there, by the way, like Postman and stuff, but Docker is kind of what people think of when they think of containers. So microservices. So we have a monolithic application over here on the left, and it has the entire business logic, the entire data access layer for just one app or two apps in a lot of enterprise data center applications. But for a microservice application, like I was talking about before, you just get the microservices that the application needs for its interface. And that's it. So just the required libraries or frameworks or config files or whatever. And that makes it much leaner, faster, and that way we can pack a lot more in a lot less space. All right, here's what we're talking about: orchestration. So some of the tasks that my heterogeneous automation needs to conduct, imagine a 1-acre data center. They're usually not that big anymore, but it's huge. It's got lots of noise in it. If you've never been in a data center, like an enterprise data center, arrange a tour if you can, because it's pretty amazing. But things that we'll need to do is scale. So for instance, I might need to take some of the hosts and change the number and the location of my containers. Provisioning. I might need to set up containers or set up hosts, but I need to do that not just in this data center, but in 5 or 6 data centers around the world. I might need to deploy a certain class of container or configure, or maybe set up high availability. Let's say that in one data center, they're doing a hardware refresh on a whole bunch of their racks. And so I need to live migrate a huge number of containers, let's say hundreds or thousands of containers from that data center and spread them across a regional data center somewhere automatically while people are still using it. I'm using Gmail and they're taking that container and they're migrating it to another location and I won't even notice, because we have orchestration, automatic provisioning, health monitoring. So we're checking, oh, wait a minute, look at that container over there in that northeastern data center. It needs a patch, as do several hundred others. Let's update that. Let's load balance across multiple data centers, across multiple hosts. Let's make sure that we have the appropriate resources, memory, networking, etc. All of that can be orchestrated for all these heterogeneous workloads through tools like Docker Swarm, tools like OpenShift, but especially, as we talk mainly about in this class, the main tool being Kubernetes. So what is this Kubernetes? Well, Kubernetes is sometimes called K8s. It's an open source, portable, extensible. That means we can add stuff to it, change it around. It's an orchestration platform developed by Google for the purpose of heterogeneous automation of containers and container infrastructure. It's pretty amazing. So if you look at how it works here, it does discovery of services, load balancing, this entire list that we see here. At the center of the Kubernetes cluster architecture is the Kube API server, which is responsible for helping with cloud controller management. etcd is actually pretty huge. I'll talk about this a little bit later. Kube scheduler. We have kubelets that are running kube proxies and kube nodes. All of this in the cloud. All of this to help orchestrate the vast containerization of software in the cloud. There's another type of cloud computing that is used quite a lot. It's called serverless computing, otherwise known as function as a service. And this, it seems to go in and out of vogue over and over again. Sometimes developers are saying, functions as a service, serverless computing, that stuff is so last 6 months. And then they're like, oh, wow, that's the best thing ever. So in developer communities, we get a lot of this arguing. But what does it do? What it does is it allows you, while you're doing your dev, your application development, is you can offload some of the specialized compute from your app to AWS Lambda or some other cloud compute. And so we have somebody who's running an application, and they are going through an API gateway, and they're receiving these services from serverless functions. One of the simplest ways to look at how this works, serverless computing, and really you need a slower internet connection to actually see this happen. But if you go to YouTube and you open it up in a very small window, and it's like the lowest possible resolution, and then you change the resolution to like 180p, you'll see a little swirling icon for just about 200, 300 milliseconds. So not even quite a second. And then you'll get your full high-res video. So in some cases, what you can do is take that functionality in your app that normally would take up a lot of the compute cycles in your app and offload it to AWS Lambda or some other serverless function. It does the compute for you. It does that complicated stuff, then passes control back to the app. That's just one way of doing serverless computing. So it eliminates the need to manage that back-end compute. Instead, you offload it to serverless computing. We're in objective number 2, and here in objective number 2, we're going to talk about some cloud threats. Cloud threats, they're everywhere. There are threats to cloud security. There are risks to Kubernetes. There are risks for serverless security. And I want to tell you this in advance. We're going to not get into every single threat. If you want to study these, you can do so. But I mean, we see ownership and accountability and multi-tenant. Look at it, physical security. Someone breaks into your cloud data center and steals one of those cloud servers. We have lack of centralized policy management, insecure. Hey, we talked about that. This one here, look at this, almost this whole stack. Injection, XXE, XSS, etc. Insecure deserialization. We talked about a lot of that. We also have cloud computing threats, a myriad of them. Like, for instance, data loss because of a data breach at the cloud center. Maybe encryption keys have been lost. Maybe there's an unknown risk profile. We didn't really know what we're getting into when we signed the contract. Oh, you should have read the contract. Natural disasters. A tornado is heading towards the data center. And they say, lock down the data center. A tornado is coming. And then an earthquake happens and swallows the entire data center. Don't you hate when that happens? Yeah, all of your stuff goes offline. Everything from there to supply chain, network traffic issues, lock-in, deplatforming, privilege escalation, you name it. I could probably come up with several more, but I decided to come up with AI threats. So one of the things that we have on the drawing board is a lot of quantum capability. And one of the things we have right now is AI. So I asked my friendly LLM to put together a quantum and AI cloud computing threat picture, and this is what it came up with. Look at all that, all the rain, the cloud, and I like it. I thought it did a good job. I probably could have drawn better if I had 4 years of art classes. Just maybe, but probably not. All right, so the next thing that we look at then is some of this list. Check it out. So AI-powered cyber attacks, which I think you could imagine. Autonomous, adaptive malware that evolves in real time, outpacing traditional defenses. Advanced data manipulation, generation of synthetic data. So do you know that we've exhausted all human data for all time? Isn't that insane? That AIs, LLMs, have scraped all of human knowledge that can be found, at least that's not locked away somewhere. And now they're creating synthetic data. So synthetic data is when you take real data, a couple of data sets, and from there create something unique based upon those data sets. And so synthetic data is becoming a big deal for AIs. And so that's indistinguishable from real data that might compromise the trustworthiness of clouds. What about AI-powered social engineering? We talked about that too, right? Mimicking human behavior and voice, making it difficult to distinguish between the real and the unreal. Encryption breaking, because I included in my query, I included quantum computers. So potential decryption of sensitive data because of cloud quantum computing, because we're having obsolescence in our old school encryption protocols. Quantum power data breaches, quantum computing enabling attacks to bypass current security measures, leading to large-scale data breaches by exploiting quantum-specific vulnerabilities using that old Shor algorithm. Quantum AI attacks. Quantum enhanced AI enhances it exponentially, increasing the efficiency of AI-driven attacks, processing and exploiting vast amounts of data faster than ever. So we are in an AI era. We are closing in on a quantum era. So it's not just those threats that we're talking about before. It's a lot more. And all of that applies to some of our container vulnerabilities where we get an impetuous. How impetuous can you be, Mr. Image? Yeah, impetuous images, right? Just careless creation of images. You're not considering. You don't care. I don't care. I'm a prima donna. I don't care about your security safeguards. I'll make my own image, right? Unreliability of third-party resources. You get container images from somewhere else, and they're not reliable. Unauthorized access to accounts. Insecure container runtime configurations. Exposure of that data in Docker files. So there's a lot more embedded malware, non-updated images, and because they're not updated, they're hackable, and hijacked repositories, and many others. And then we go to Kubernetes vulnerabilities, a huge number of these too. No certificate revocation, or maybe unauthenticated HTTPS connections. Both of these can expose Kubernetes to a lot of attacks. So non-consistent time password comparison. This is at the Kube API server because it's running basic password authentication. Hard-coded credential paths and many other things. Let's jump now, instead of talking about Kubernetes and containers, into basic cloud attacks. What you're more likely to see just hanging out in AWS, Google Cloud, or Azure. So with a cloud attack, one of the worst is a service hijacking using social engineering. So what's going to happen is there's a fake cloud page that the attacker entices somebody to click on, they grab their credentials, and they hijack their cloud. Another one is using sniffing, where we're running a sniffer and we are sniffing login credentials, and depending on your level of encryption, et cetera, that might be possible, but that's a slight possibility. Next one we look at is cross-guest VM breaches. And so we're in the cloud and somebody sets up a malicious virtual machine. So this is what the attacker is doing. What they're trying to do is analyze the cloud provider environment and then maybe steal cryptographic keys, secrets, et cetera. They can do timing attacks. These are side channel attacks. Data reeminence, acoustic cryptanalysis, like listening in on the vibrations, power monitoring. So these are all side channel attacks that we do for cross-guest VMs. Then we have a wrapping attack. So a wrapping attack actually involves a SOAP message. So with a SOAP message, remember we talked about SOAP when we were going and looking at application hacking, and we're looking at the some of the different application architectures. Well, SOAP is something that's used at the back end. So let's look at what happens in a SOAP wrapping attack. As you recall, perhaps, SOAP stands for Simple Object Access Protocol, and it is vulnerable. It's an older protocol. It is usually managed within TLS, out in transport layer security. So here's how it works. If you look on the far left, this is a real user. He's sending a request to a web server, and it's typically packaged as a SOAP message, which has both a header, and the header, SOAP headers have metadata in them, and a body that has the actual data or the command. So we see both of those over here. So what's going to happen is the attacker, this dude right here with the hoodie again, is going to intercept the SOAP message in transit that's going between that user and that server. And how is he going to do this? Well, maybe some type of MITM, little man in the middle attack. And so what they're going to do now is modify that SOAP message, specifically looking at modifying the body of that message, and then create an altered body, a duplicate body, or something like that. And then they're going to send that modified message to the server. And when they do that, the server really has not revalidated it or anything like that. And so the message gets passed on, and they have done their wrapping attack. So this can cause unauthorized access. It can cause data compromise and many other things. Let's look at another type of attack. This is not a man in the middle. This is a man in the cloud. But you'll see it's basically the same thing. So what we have here, it starts, so many of these start with this, tricking that victim into clicking some type of link. They get malware on their system, and it allows the attacker to get into that person's cloud, whether it be their drive, whether it be their cloud workloads. And so a lot can happen. There can be back-end communication, command and control, remote access to the cloud and to the local infrastructure. Another one is a cloud hopper attack. This is actually a very interesting one. This is attack against or maybe through a managed service provider. So what's going to happen is this attacker here, you know what he's looking for? He's looking for specific individuals in the managed service provider, sending spear phishing emails with custom-made malware that's going to run on the back-end infrastructure of the managed service provider. So he sends that in, it makes it here, somebody clicks on it, does the wrong thing, and so now this attacker gains access to that back end, to the managed service provider, which might be able to give them access into the cloud environment also. There's another one, cryptojacking. People can make a lot of money cryptojacking. What we're doing in this case is we're stealthily mining Bitcoin or some other type of digital currency. And again, we start off with the attacker somehow, probably with an entice to click or with some other back end or front end exploit. They are compromising the cloud service. The victim connects to the cloud service. And then the victim is actually the one who accidentally starts the crypto mining. And it sends and reaps the reward. Those rewards are sent to the attacker. Cryptojacking. The next one is a cloud-borne attack. So let's go back to the attacker. This attacker is going to get their hands on the hardware side of stuff. So he's going to, let's say that Dell or HP or some offshore manufacturer of hardware that's used by the cloud provider, they're going to install a bare metal backdoor. Now, we take all of these servers, ship them to the cloud provider, Azure, AWS, or whatever, and a new customer is assigned to that server, and this attacker now has a backdoor into that the users on that hardware. Another one would be an IMDS attack, and this is an instance server metadata attack. Let's have a look at how that works and do a little bit of a dive into it. So the instance metadata server attack, what is it? Well, it's a security vulnerability, and the target of this vulnerability is the compute environments in the cloud, specifically like EC2 with Azure and Google Cloud. And so what IMDS, if you look over here, provides a very important critical metadata about a cloud instance. Details about the instance, about its network. If you look over here, its software, the configuration. And so the metadata can be accessed, and you can get information like identity documents, etc., sensitive data. So here's what happens, is the attacker exploits a 0-day vulnerability. So you have to have one first, of course. Something that was previously unknown, a flaw in the software, hasn't been patched, hasn't been mitigated, and so this is particularly dangerous. Next thing the attacker could potentially do is exploit a misconfigured element of the cloud services, or use data that may have been leaked through something like a reverse proxy or something like that that's been set up for administrators. So there are a couple different ways that the attacker can get into here. So let's look at the next step here. The next thing that's going to happen is the attacker is going to capture the EC2 data. So there's where we see there. So once the attacker gets access to the vulnerable instance, they can query the metadata, the IMDS, and retrieve that metadata. and get those API tokens, get those instance identity documents, get that user data, and gain unauthorized access. Look over here to all those cloud resources. So this can actually spread from here and lead to a broader compromise, a data breach, lateral movement, privilege escalation, disabling or even restricting the IMDS access or things like that. So we could use IMDS version 2. We can use regular patching. There are many other things that can happen that we can do to defend against these types of attacks. All right, so let's look at another type of attack. This type of attack is called a CPDOS attack, sometimes called a CDN attack. So what we have here is the focus on CDN. So if you look over here, Content Delivery Network. So if you are taking this class right now, very likely it's distributed to you through a content delivery network. If you have ever been on Netflix or Hulu or some of these other services, that is delivered through a content delivery network. It helps to smooth out and nationally and globally distribute content. And so this is here what we're doing. If you look at here, it says cached poison. That's the core of what's happening here. It's disrupting the caching mechanism. So the first thing is that this attacker is going to send in a malicious request. They're going to initiate this attack. They send, essentially it's a specially crafted right here, HTTP request to the origin web server, and it's going to be designed to be malformed, or it could be designed to be oversized. It's going to try to trick that origin server into responding with an error or with specific malicious content. So once that happens, then what's going to happen is the request is going to reach the origin server. And what's going to happen is this origin server acts as a cache for content. I mean, that's its whole purpose, for to reduce the load on that origin server. It's going to forward the malicious HTTP request back to the web server. So here we go, responds with an error. And that is critical for this. And so the error or the malicious content response has the origin server, when it gets that malformed or oversized request, you might get 404, like you see here. Do we get a 4? Yeah, there's a 404 right there. 404 not found, or maybe malicious content, depending on the type of response that was crafted. And what's going to happen now is the service is going to be cached on the CDN server. So the user requests content over here, and what happens is when they make that request to access a web page or a resource that is supposed to be cached by the CDN, and then the delivery response is poisoned when it goes back to that user. So it could be an error page, could do some other method of disrupting that content to that user. So how does it look from the user perspective? So let's say that I go to Hulu and I click on a movie. Let's see, what movie am I watching? Yeah, The Matrix. And so I click on that and nothing works. I get an error. Or maybe even going to the service itself, I get an error because of a CPDOS attack. Another one that we have right here, let's do a little bit of a dive into this. This is a cloud snooper attack. And this is an attack specifically against AWS security groups, or SGs. So you see that right here, AWS security groups. And so here's how it works. Number one, this attacker dude is going to send a malicious C2 packet from their command and control server. We see that right there. And it's going to be specially crafted. They're going to be designated to use port either 80 or 443, which are very common, especially 443, to allow through AWS SGs, because they work with HTTPS, right, and HTTP. So the next thing that's going to happen right over here is the exploitation phase. And so when you look at security groups for AWS, they typically allow traffic to these ports, right, for 80 or 443, because it assumes they're legitimate. So therefore, it's going to forward that traffic, those packets, without any additional scrutiny. That's what the attacker is exploiting. Then we see here the rootkit. Rootkits, we talked about those a little bit earlier in earlier modules. So on the target server, the attacker, they've already installed the rootkit already. So it's there waiting. Maybe they exploited vulnerabilities in traffic filters, or maybe they did some type of supply chain attack, or maybe they did a brute forcing attack on SSH credentials. Either way, this rootkit is the key to the attack. In fact, you'll see that it is right there central in the attack. Let's keep on looking at what we're doing here. So the next thing that we do is there's a Trojan on the target. So here's the target server. There's the Trojan. Hey, it even looks like a horse. What do you know? It's historically correct. And so the rootkit works in conjunction with the Trojan that's installed in the server. The Trojan is actually going to do the one that be the one that processes the commands that are received from the attacker's C2 infrastructure. And then there's going to be, let's see, number 5 over here. We're going to do identification and forwarding of the traffic. So the rootkit identifies the C2 traffic, looking for specific ports. Let's see, this has some of the ports right over here. 1010, 2020, 60, 70, 70, 80, 80, 99, 99. And then it forwards that traffic internally to the Trojan. And then there's a reconstruction of the packet where the rootkit is going to reconstruct the C2 packets. Make sure that they're disguised as traffic that's too legit. It's actually just regular, legitimate traffic. And then that reconstructed, legitimate looking traffic is sent back to the AWS security group, and it looks like regular outbound traffic. So that's how the Cloud Snooper attack works. Really, it involves a deep understanding of how AWS security groups work, and it allows for things like stealthy, very stealthy attack, data exfiltration, and many other things. So to mitigate it, we really want to do more monitoring, strict security group roles. When you're in AWS, there are some standard roles. You want to actually create stricter roles of your own. And then, of course, regularly auditing what's going on with those security groups. All right, the last one in this section I want to do a little bit of a dive into is golden SAML. So we've talked about golden stuff. Golden stuff means, so if it's an Active Directory, if it's SAML, if it's a ticket or whatever, it means that essentially the infrastructure cannot tell the difference at all between you, who has the golden ticket or the golden SAML or whatever it is, can't tell the difference between you and which is an account that was obtained fraudulently and a regular account. So that's what golden means, and that's what you're going to see here. Let's have a look here. So what we have with the golden SAML attack, SAML, we've talked about that a little bit before. It's a security, assertion, markup language. We talked about how you can use SAML in federated services to exchange tokens, and things like Active Directory federated services uses it. So with a golden SAML attack, there's an initial compromise over here, number 1. So the attacker is going to gain access, maybe through something like ADFS, Active Directory federated services, giving them access to steal the token signing certificates and the private key. And then that private key, by the way, is used to sign SAML assertions, or little tokens. So what the attacker is going to do then is it's going to use that to craft forged SAML tokens. Using that forged key and certificate, the attacker is going to then be able to just generate forged SAML tokens or responses. And then the tokens can be used for a variety of things. They are the root of how identity is created and managed. So this attacker will be able to go anywhere they want in the entire network with impunity, and with a golden SAML ticket to do whatever they want. So definitely you want to make sure and defend against that. All right, let's look at living off the cloud. Remember, we're talking about living off the land. We're talking about a specific type of malware that lives off the land. The stuff that it needs is all there. And this is living off the cloud. So what we're doing is exploiting the infrastructure of the victim using legitimate tools, using legitimate cloud services to carry out the attack. So if we look at this, we gain initial access to the system. Okay, so This is module 2, 3, 4, 5, and 6. Maybe a few other modules. Right? This number 1 is a lot. Gain initial access to the system. A lateral movement using tools like CMD, PowerShell, CertUtil. Like these are already there. They're part of the environment. Delivering malicious payload using cloud storage services like Dropbox or Google Drive. Hey, it's legitimate. It's already there. Using command and control, using ngrok, cloud service, or performing malicious activities, binding malicious traffic with legitimate cloud traffic for your SaaS apps. So it looks completely legitimate because it's not creating new binaries or anything like that. It's living off the clouds. Lot C. All right, so legitimate tools, cloud services, living off the cloud. We're in objective number 3, where we're talking about explaining the cloud hacking methodology. Let's get into it. So you want to hack the cloud. Well, so do I. It's got to be fun. All right, so with cloud hacking, there's a huge range of activities. We have application level activities. We have network level activities. We have hardware level activities. It's almost like everything combined. So yeah, web, system, and then cloud platform. So there's a lot kind of mixed in together with cloud hacking. And just like with regular hacking, the first thing you want to do is module 2, footprinting and reconnaissance. We want to gather information. Module 5, finding vulnerabilities, exploitation. Module 6, and then post-exploitation. Module 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. After the exploit, we have a lot of choices that we can do to stay long-term hacked. And so that's what we're doing. We're moving through the cloud environment. So one of the first things you want to do is identify the environment. You could be in Azure. You could be in AWS or whatever, the Google Cloud. You can use tools like Shodan and Census to get detailed information depending on how that cloud resource is set up. So ssl.cert.issuer.cn:\Amazon, and we're going to look for Amazon services. So we can look for cloud services by region, by vendor, by product like Kubernetes or whatever, giving you some of the searches there. Also, let's say that what's your favorite LLM? You've been in this class for quite a while. Have you been looking at large language models? Have you been making more use of ChatGPT? Have you started using any of the open source models from Hugging Face? Have you experimented with some of this stuff? You should have. If you haven't, not just the labs, you should. This is something that you should be constantly keeping track of, experimenting with, and getting used to. Because remember, if you are not using AI, you're falling behind. So my point is this, is that you can say something like this. To search for AWS services, I can use Shodan and use ssl.cert.issuer.cn:\Amazon. What search criteria would I use for Azure? What criteria would I use for other clouds? And have it give you a list of commands. So you can get those commands from your friendly large language model AI. Then there are tools, and we can use tools of various types. And so I'm going to give you a little bit of a warning here. This module from here on out is extremely tool heavy and extremely full of tables and so on. So we're going to talk about the tool and do an overview, talk about some of the elements and some of the tables, do an overview, but we can't just go into every one of them necessarily. But these are things that you need to know for the exam in terms of what it does overall. So for instance, you might have an exam question that says, Fred, a cloud engineer at CEH Corp, is looking for a tool that's useful for identifying open ports and services running in the cloud infrastructure, enabling a quick discovery of exposed services that might be vulnerable to exploitation. What should he run? Hootsuite? No. Shodan? well, would I get exposed services? Well, I won't leave shorthand in there. Say Hootsuite, let's say BoopSuite, stuff like that. It gives you several different tools, and one of them is Masscan, and the only one that is a cloud, the only one that's a cloud will be on the exam. So in other words, you need to know that Masscan is a service that can be used to find ports and services, et cetera, running in the cloud infrastructure. Unlikely, but possibly, there might be a question like this. So Fred, a cloud engineer at CEH Corp, would like to find targets for IP addresses and open ports on the cloud. What command would he use? Sudo masscan -target find -IP address. You want to run a script. So a script would be cloud find or something like that. And then the third one would be sudo masscan P0 through 65 target or something like that. So in other words, sometimes you need to know a basic command for it, but usually it's going to be the actual product with a little bit of additional information, right? So anyway, know that that's the purpose of Masscan, and hopefully you'll be able to get that if it's on the exam. Prowler, what's Prowler? Again, we're doing enumeration. Check security. Here's another exam question for you. So Fred, a CEH engineer, a cloud engineer at CEH Corp, is looking for a tool to check for security loopholes in the cloud, including unsecured data transmission channels and overly permissive policies. What should he use? Should he use Nmap? No. Hootsuite? No. Masscan? No. Prowler, right? Even I probably wouldn't include Masscan in there because that's a cloud tool also. You need to know that it is a cloud tool. Now, every once in a while, like I said, there will be a command, like it might say, Fred is trying to find, to generate a report from what he found in CloudScan, and what command would he use? Prowler M CVS JSON would be the command, but they would give you some couple other products that are not Prowler, and then a wrong Prowler one and a right Prowler one, right? So that's another type of test that you get. So anyway, these are vulnerability scanning with Prowler. Other things that we would do is use CloudSploit. It helps you to look at your policies, look for misconfigured network settings. Oh, and one more thing about the exam too. Sometimes we have resources in the module that we double up on in the lab, and those are more likely to see exam questions than ones that aren't doubled up in the lab, just FYI. But anyway, we can find this. This is actually a pretty cool tool, CloudSploit. Another thing that we need to do is maintain stealth. So clean up, maintain that stealth. So you compromise the environment, you want to stay under the radar. So manipulating logs, removing extra credentials, and manipulating configurations, and maintaining that persistence through a variety of mechanisms. Here in objective number 4, we're going to be looking specifically at AWS hacking. Hey, let's have a look. So with AWS, one of the biggest deals is S3 buckets. What are they? They are blob storage. A blob is a binary large object. It could be a video. It could be an MP3 file. It could be a Microsoft Office document. It could be anything digital, electronic. So that's what it is. And it's called Simple Storage Service S3. There are tools like CloudBrute, S3 Scanner, Bucketfloss, Bucketloot, and others to find open, flawedly implemented S3 buckets. And what you see over here, we're using S3 Scanner, and down here, we're using Bucketbrute. And then we get into advanced Google hacking. So this is the use of Google Dorks. And so we see this in URL S3. We can find buckets by using Google Dorks. I've found many of them, and they're open. You can look inside them. Some of them are attackable, but for the main purpose a lot of these are like, for instance, a professor or something like that, that has stuff stashed in the bucket for students. Also, we can use Cloud Brute, and this is just an example of the line that you would use, Cloud Brute-D, give it the keyword, etc., and you can pull out information from an S3 bucket. Another thing that is important to do in hacking AWS is enumerating EC2 instances. So an EC2 instance is essentially like a virtual machine. And so with this, with Elastic Cloud Computer, EC2, we have commands. And so if you look at these, this AWS EC2, what kind of hacking tool is that? It's not a hacking tool. It's just the AWS command line interface, the CLI. So with AWS, with Azure, with the Google Cloud, all three of them have CLIs, command line interfaces. And in those command line interfaces, you can run commands for the vast majority of resources in the cloud. And so we can do this, describe instances, right? Describe volumes, describe snapshots. We're pulling in information and using that describe modifier to find out information about all of these resources. So this is just a CLI. Remember, admin tools are hacker tools. Then we move into RDS instances with AWS. And so we can use the CLI to go find RDS instances too. These are a type of very easy to get into and use relational database. That's what RDS stands for. And so we can use AWS RDS describe. Again, so we're going to do RDS describe and find out specific information about each element of that relational database. Then we have IAM roles. And so these are identity, user accounts, essentially. So what groups is the account associated with? What resources is the account associated with? Finding resource names and policies and roles and getting that information out. Yeah, we can use the CLI for that also. There is a very cool little tool called Cloudsplaining. And what it's going to do is help you enumerate weak IAM policies. So let's say the junior administrator. I like those questions. I've seen those in Cisco exams and Microsoft exams and EC Council exams. A junior administrator misconfigured a share. And then they go into the question. But either way, the junior administrator made a weak IAM policy. So we use the cloud, again, what? The CLI to go grab information. So we're doing an AWS IAM get-account-authorization-details and telling it to output it to JSON, right? So cloud splaining scan, and we can also do a cloud splaining scan and get the information about what is happening with those IAM policies. There's also AWS Cognito. What is Cognito? What it does, it helps with authorization, authentication, and user management, helps us streamline it all. And there is a command at the CLI level to access that resource on AWS. So AWS Cognito IDP, AWS Cognito Identity, AWS Cognito IDP sign up. So existing users, identity pools, user pools, we can enumerate at the CLI, AWS Cognito. And then we have Ghostbuster. So this is looking at AWS accounts, and we're going to be enumerating those DNS records of those accounts. And so what we're going to do is take advantage of Route 53. So you gather those, and by the way, 53, what's that? Port 53, UDP, TCP, that's DNS. And so that's why their major DNS server is Route 53. So you can run this command to enumerate the DNS records of that account. So we do Ghostbuster scan, and then we give it AWS and all the rest of the information. So they're showing you the help here in this parrot screen for Ghostbuster. Then we need to enumerate resources, and there are a million resources possible in AWS. So you want to get Lambda resources, you use AWS Lambda list functions. So a variety of Lambda. For IAM, we could list attached role policies, DynaDB, and API gateways. So these are just like a very small sampling of the commands we can use to get to resources. There's another tool for attack paths. This is called cartography. And what the purpose of it is to identify relationships between elements, dependencies between these elements, maybe even find misconfigurations. And so you would run the command and it'll go through and search for the different elements and their relationships. Other tools like Starbase and AWS Recon and Cloud Mapper do some of the same stuff as cartography. And then we look for attack paths using CloudFox. CloudFox will run a scan. This is actually, if you look, it's hard to see this, but it says CloudFox, AWS double-dash profile, and you give it the profile, and this one they're doing all dash checks, all checks. And so now it's running through its inventory, instances, lambdas, file systems, and it goes on and on and on, just doing all checks. And we can see that command right here. We're finding exploitable attack paths. And so elastic interfaces, access keys, permissions, workloads that have permissions. Also, we want to see if there are any SGs or security groups that are exposed to the internet, and maybe we can gain access to those. So open security groups, they might accept traffic on ports that we can exploit. And so the techniques would be, number one, from the management console. So you have to have a modicum of access, right? So you have to go to the EC2 dashboard, select security groups, and then you can review the security groups from there. From the CLI, you have a command to identify your security groups, and that's going to be the AWS EC2 describe-security groups. Hey, go figure. Pretty simple command. We also have a nice little tool called Red Team. This is a tool from Stratus, and it's actually called Atomic Red Team for the cloud. And what we're trying to do is emulate an offensive attack looking at a very granular, contained manner. And so this is used against Kubernetes, GCP, Azure. And so this is an example of the command itself. So Stratus, list, double-dash platform, AWS, double-dash MITRE attack, tactics, and persistence. And it goes through and tries to find areas of weakness. And so there are a variety of attack routines that you can run using Stratus. And remember, we're talking about IMDS, getting that metadata a little bit earlier to get metadata so we can get cloud keys, gain access to instances, etc. Some commands, these are actually just regular Linux commands, curl. And so what we're doing is we're going and pulling that information out with a curl command, those security credentials, the IAM role names. They're showing you the results of some of those commands right down here. Other things that we can do with AWS is exploit misconfigured AWS buckets. Identify the buckets first. How do you do that? S3 Scanner, Lazy, Bucket Finder, S3 Bucket Brute Forcer. These are very good tools. Or maybe just find the URLs of the buckets using Google Dorks or whatever, like we were talking about before. And then we need the CLI. And then we need to go extract access keys using the CLI. And then we can figure the AWS CLI with the information we have. And then we can identify vulnerable buckets by running an AWS S3 LS S3 bucket. So we're going to list out all those bucket names and then exploit them using a variety of CLI commands. Another item that we can do is we can compromise AWS credentials. And so there are a variety of ways to step through this. Number one is looking for repository misconfigurations to be able to access IAM keys in AWS. Social engineering, fake emails, you could text people, make phone calls to get IAM credentials. Maybe find out if passwords have been reused over and over again. So you can maybe use dumpster diving to find passwords and then see if they're reused. Vulnerable AWS hosted applications. So maybe somebody is hosting a pretty badly architected application, and then we could do a request server-side request forgery to steal those credentials, exploiting a third-party software running on AWS, or maybe find somebody on the inside, take them to a bar, be nice to them. Remember that? We talked about that, elicitation. If you are really good looking, maybe you could be a honey trap, or you could put on one of those rubber masks. Either way, those are ways of insider threats, right? Getting somebody on the inside. I might have to get one of those. So the next thing we look at is Pacu. And this is used to hijack misconfigured IAM roles. It's a very nice tool. It's been around for a while. Keeps getting updated. It's well used. You can use assume role and go grab those role permissions, hijack roles with Pacu. Another one, I just mentioning dumpster diving, right? This one, though, it doesn't dumpster dive in an actual trash can. What it does is it examines a huge volume of file types, and it looks for hard-coded keys, and they're looking for those leaks of those hard-coded keys that you might not otherwise find. That's dumpster diver. And so you can scan a directory, you can scan for AWS keys. Dumpster diver is pretty good that way. Another one is called CCCat. CCCat is a Docker container on AWS exploit tool. And so you can abuse credentials. You can pull that Docker image. You can see a little bit of a picture of CCAT even does backdoors, and it helps you backdoor the image. The next thing we look at is shadow admins in AWS. This is actually a pretty interesting way of doing things when you're hacking AWS or other cloud resources. What you want to do is create an account with very good permissions that will allow you to get behind that cloud network, escalate privileges, take control, etc. So one of the things you can do is elevate your permissions. Now, it's not always possible, but you might be able to go to the Microsoft authorized elevate access action and just go ahead and elevate your privileges, or maybe modify a role. Or maybe if you can't modify a role or you can't elevate permission, just create a new account and then give yourself the appropriate permissions. One of the tools that we see is Skyark. Skyark has AW Stealth and Azure Stealth. These are the two modules for scanning. And so with this, you might discover repositories that have risky permissions that then you can then use to elevate privileges. Then we have SSRF. And so with SSRF, we can potentially use this to get AWS IAM credentials in a web application. We're going to run this from the CLI and configure it. And as you notice here, look at this, AWS STS get-caller-identity from a specific profile. Or we can get more information with an ls command out of that profile. So we can use SSRF for getting information on AWS. There are attacks against AWS Lambda. Now, we have two major scenarios in any pen test. That would be a black box scenario and a white box scenario. But let's have a little bit of a dive into what we're doing with the black box versus white box scenario. So again, our attack is against a Lambda. And so what's going to happen is, as an attacker, you're going to have to make some educated guesses. So it involves the attacker really not having any real good information, no prior knowledge about the internal workings of the environment he's about to attack. So you're going to have to make some educated guesses. And then maybe from there, we can exploit the infrastructure, targeting those Lambda functions in S3 buckets. So how does it work? The first thing is we want to be able to access without credentials. So you start assessing the S3 bucket. You don't have any prior credentials. And if the S3 bucket is misconfigured, or it will allow public access, or maybe unauthorized access, then this one might work. Like I said, you can still find some like that. The next thing you want to do is upload a file into the bucket. So like it's going to be a malicious file. And what we want the malicious file to do is interact with the AWS Lambda function that's associated with that S3 bucket. So that's what we're doing next. And over here, we have the Lambda function trigger. So the Lambda function would automatically be triggered when that file is uploaded, and the function will process the file. It'll calculate tags, do other operations. But if the function itself isn't securely coded, it may actually accidentally or unintentionally expose some of that sensitive data, or maybe even you can get it to execute commands. Exfiltrate credentials is what you end up with. So the attacker will then be able to exfiltrate credentials, exfiltrate other sensitive information. Maybe they've embedded commands or scripts within the uploaded file that the Lambda function executes, leading to credential leakage. And we don't usually examine all of the commands, but let's have a look here at just a little bit about what's going on. So there's some commands. The first thing you want to do is look for objects that are within specific buckets. And so that's what we're going to do here in this command. We're going to look for tags. We might even create a new connection. We see over here with the EC2. We might even use an environmental variable to interact or extract those credentials. So quite a lot that we can do in and with Lambda. All right, the next thing we want to look at then is the idea of a white box scenario on Lambda. So in this case, we have more information, more access. So let's have a look, dive a little bit into this one. So with this one, again, we have a white box scenario, and it's not like the black box. Where in this case, we have some information about the environment. And so we can do a much more targeted attack. So the first thing we want to do is make sure we have those credentials. So that's number one over here. So you get the user credentials. How do you get these? Well, maybe you'll social engineer them, or maybe you'll do phishing. Either way, you have valid credentials now. So what we're going to do is gain access to the environment. There we go. Social engineering, gain access to the environment. We might leverage prior knowledge. So we use those credentials. Then we access the AWS environment, gather more information. We might check the user policies associated with the compromised account. Maybe we'll use commands over here. Check it out up here. We can use commands like AWS IAM, list attached user policies, username, stuff like that. So we can start executing these commands. And then what we're going to do is we're going to list the Lambda functions. We see that in step number 3. And so we're going to list those functions in our environment using commands like AWS Lambda list functions. We see that right up here in that third bullet point. That allows us to identify Lambda functions that might be vulnerable. And then step number 4, this nice long one down here, we're going to further investigate commands, specific functions using things like a Lambda get function, corp function, easy, that's right down there, to get more information, detailed information. And then over here at the very top, we can exploit that function with all that detailed information. You could download Lambda code for further analysis even and make use of that. So you get a deep exploitation in this case. You can do code tampering, resource misuse, and really what you want to do to mitigate against white box, especially a white box Lambda hack, is to tighten down your credentials, your IAM. And that's very important. We'll see a little bit of that when we get into the lab. All right, so another type of attack against AWS is a privilege escalation technique. And there are several that we need to look at. We can create a new policy version. If we can do that, we control the policy. Assign the default policy version to an existing version. So that way, we still have some control. And then we create an EC2 instance with an instance profile. And now that takes a little bit of that control, passes it into the EC2 instance. And then we create a new user access key. And once we do that, then we are ready to roll. Next thing we're going to do is we're going to create or update a login profile that's showing you some of this. And this is not all necessary, but usually we follow most of these. And then we're going to attach a policy to a user group role. And again, if you're not familiar with AWS, you'll see more of this when we are in the lab. It'll make a lot more sense. And then we create an inline policy, add a user to the group, and now that we're part of that group, we can use the privileges associated with that group to gain further access, and we've escalated privileges. Another thing we can do is create backdoor accounts. Endgame, Paku, very good tools to help you create backdoor accounts in the platform. You can run multiple endgame commands to list resources, buckets, across services, and create a backdoor, right? So endgame expose service, and this is the command that we use to create that backdoor in endgame. What we want to do also when we are in AWS is be aware of what some of the primary functionality in AWS is. And the thing that's watching you, it's like the big eye, keeping an eye on everything you do. Now, this is great for business owners, for developers, and so on. But for an attacker, having you being watched all the time by CloudTrail, I tell you what, the engineers, the administrators, they're going to find you. So what you want to do is disable all the logging functionality. So all of these are lists of CloudTrail commands to go through and iterate through shutting down all of that CloudTrail tracking. And then we maintain access, clear logs. So we're showing creating new instances, inserting backdoors, manipulating access to keys, and so on. So all that's part of maintaining the access. One of the items that we're going to manipulate quite a lot in hacking AWS is EC2 instances. So in this case, we're going to use that to establish persistence. We're going to stay in the cloud for as long as possible. So one of the things we can do is create a backdoor user. So what we do is create a new user. You see the the CLI command using IAM, AWS IAM, and we create that username with the policy, etc. So we have a new user. We can also set up startup scripts, inject SSH keys. We can install rootkits and leverage IAM roles. Now, what we can do is if we have a clear path, we can even write scripts that when we run them, they will take accounts that we have temporarily suspended and turn them back on and make use of those. There's a lot you can do, but this is more of a white box kind of hack because you have to have at least some access to the cloud. Another thing you could do is lateral movement. Well, let's say you're in the Northeast data center and you want to go to another region, right? So you can move between regions of the world, of the country. So you want to make sure you don't gain access. You change that IAM role policy. You list roles first, and then we have the steps. I've done this before in almost all the clouds, is move all your workloads from one region to another, and then they disappear in the primary region, and maybe you won't be discovered because of that. And then we have the DAM vulnerable AWS infrastructure, and this is called AWS GOAT. And what it does is gives you a practice. It's realistic. It's hands-on, simulating real-world attack scenarios. So if you don't have an AWS account of your own to hack, or you are afraid of, getting in trouble, this is one for you. You can do SQL injection, ECS breakout, server-side request forgery, IAM and file upload exploits, all under the auspices of something that's created to be vulnerable. Objective number 5. With objective number 5, we move from AWS to Azure. So with Azure, we see that you'll see a couple of the same tools, but mostly different tools. They are both based on cloud architectures that are also different. Azure was created to be a less expensive alternative to AWS, but they've turned it into a very desirable cloud service in and of its own. So for reconnaissance, we have a nice little tool called AAD internals. So that's A and then AD internals is what it is. And so this is something that will give you access to Entra ID, which used to be called Azure AD and Office 365. And so you can use it for reconnaissance. Invoke AD int recon as outsider. That's a very powerful command when you're running this. And then what you're trying to do is go get information about the AD environs for Entra ID in Azure. So one thing you want to remember when we are in Azure, that Active Directory in Azure, those identity services have been renamed to Entra ID. And to me, the name is kind of weird. But I think the reason they did it is because the identity services are so much more, go so far beyond Active Directory, that they needed a more all-encompassing name. That's why we have Entra ID. So you'll see me substitute that name periodically. So we want to identify those Azure resources. This is Microburst. It's a very nice little tool to help you go map out Azure resources. And you have CLI commands that you can run to use Microburst to find those resources. You can enumerate with Azure Graph, and there's the $$ list and $$ get and so on that we find in Azure Graph. There are tools like Spray 365 for password spraying in not AWS, but in Azure. We also have the ability to identify the attack surface of Azure using StormSpotter. And so you can enumerate resources, configurations, etc. They give you some of the CLI commands for StormSpotter. There's also a GUI that helps with the mapping with what you find in StormSpotter. We also have Azure Hound. Azure Hound is one of the tools that's been around a little bit longer, and it's great with Entra ID. Sometimes you'll still see some references back to Azure AD, which it used to be called, and you can do data collection. You see some of the CLI commands for Azure Hound to go pull information out from Entra ID, even print it out or put it into a JSON file. We can get blob storage. So this is sort of the equivalent of S3. This is storage in Azure blobs. And so this is called GoBlob. I like the name of GoBlob. And so you run GoBlob and helps you to discover sensitive information. It's kind of like an S3 bucket scanner, but for Azure. We also can look at network security groups in Azure. And I want to do a little bit of a dive into NSGs in Azure. So let's have a deeper look at network security groups. In AWS and in the Google Cloud, we don't have NSGs. What we have is virtual private clouds, or VPCs. These virtual private clouds are ways to completely isolate, separate, segregate all of the activities of your cloud workloads into a virtual private cloud. And one of the things we can do with that virtual private cloud is strictly control access into and out of not only the virtual private cloud, but to individual and collective elements within the virtual private cloud. The closest thing that we have to virtual private clouds in AWS and in the Google Cloud is network security groups in Azure. So let's have a look at network security groups and some of the differences between them in virtual private clouds. So let's have a look here. I printed this out for you. And so one of the key features is the purpose, right? So the Azure NSG controls inbound and outbound traffic to resources within Azure, whereas the AWS VPC gives you an isolated network environment within AWS, including control over networking features and security. So we see a much more isolated, more in-depth security with AWS VPC. Then with security control, we have a rule-based filtering in Azure network security groups, the rules can be applied to subnets or individual resources. And in the case of VPCs, they use SGs. We talked about these a little bit before, security groups for instance level security, and ACLs for subnet level security. Next thing we look at is Azure stateful security groups are stateful, but NACLs are stateless. So we have a little bit of a difference between stateful and stateless, meaning that if an incoming request is allowed through a specific port, the response is automatically allowed even if there isn't a specific rule. So that means that's what stateful would be. And then the scope, NSGs can be applied to our subnets, VMs, and NICs, or network interface cards. SGs are applied to individual instances, and NACLs are applied to subnets. And over here with Integrity, with other services, this integrates with Azure Monitor for logging and monitoring. This integrates with, on the other side, with CloudWatch, CloudTrail, VPC flow logs. Flexibility focuses primarily on traffic control within the Azure network, whereas VPCs are much broader with VPN direct capability. So if you were to compare the two of these services, really VPCs give you the most in-depth protection, and they're focused on taking all of your cloud resources and protecting them under one virtual private cloud. So speaking of that, Azure network security groups have CLI commands that you can use. I just want you to look at the differences between the two. When we're in the lab, I'll talk about them as we go through it. But in the Azure portal, you can go and set up and manipulate NSGs, and you can run it from the CLI. We also have Azure Functions. Just as we have AWS Lambda, this is the equivalent, right? So what we're going to do is maybe exploit an automatically managed identity to get authenticated, allowing you to get authentication without having to manually do anything. So what you do is you run your connect AZ account access token command, your get AZ storage account key. So we have CLI commands that you can use, and maybe you can exploit managed identities and get yourself your own keys, etc. There's ability to take misconfigured Azure accounts, intra AD accounts, and you can use Bloodhound or Azure Hound. So we run connect Azure AD, and then down here what we're going to do is run these commands to create a new key. So what we're going to do is we're going to store information in these two variables, and then we're going to run an export PFX certificate, and then we're going to upload the certificate. And now we're going to escalate privileges with the connect Azure AD, etc. command. So we have multiple steps, but eventually it might be possible, given the right environment, that you can use these commands to escalate privileges. You can create backdoors in Azure AD using service principles. And so we are using intra-ID roles to maintain that access across resources. Try not to leave any trace. We're using tools like PowerShell, Azure CLI, and Bloodhound, which I've mentioned before. So they give you the 5-step process to creating a backdoor and establishing persistence. We can use VNet peering. VNet peering is a way to very powerfully encrypt and allow access to resources in Azure. So you can exploit this to move laterally within a network, and it looks completely legit and completely secure. So they give you the commands to do an unauthorized peering, forward traffic, and allow yourself across the gateway, and then synchronize. All of that is possible if these commands run appropriately. And then we have a really cool little, another goat. This is yet another goat. There is a web server that I've run into many vulnerable virtual machines, WebGoat, that is another vulnerable by design web server. But either way, this is vulnerable by design. Infrastructure mimics the real world. You can do escalation, black box testing, etc. So if you want to just try it out, you can run good old Azure Goat. Here in objective number 6, we're going to look at the GCP, the Google Cloud, and discuss some of the same areas, but although a lot less than we did in Azure and AWS. All right, let's make it happen. All right, so here in the GCP and the CLI, hey, I have more acronyms. What we want to do is enumerate resources. There are commands that you can easily run, gcloud, gsutil. These are regular command line CLI commands. You can get organizations and permissions and bucket information. We can get services with a gcloud IAM command, gcloud auth command. We can enumerate Google Cloud with the gcloud compute instances list command. We can get a gcloud compute instances describe command. We can do gcloud IAM roles command to enumerate IAM roles. Oh man, a lot of CLI commands are available in the Google Cloud. There's also a nice little tool, the GCP Scanner. So in this case, what we're doing is we're just running the help for GCP Scanner. And what it does is try to determine what level of access you might be able to crack your way into in the Google Cloud. We also have cloud_enum to go and try to enumerate GCP buckets and get that metadata, get information from there, grab keywords, metadata from those buckets. So over here we're running a cloud enum, so a little Python, -k cloud, disable AWS, disable Azure. So we're not running it against those two. We're only running it against GCP. And boom, it runs and starts to find buckets. In these cases, they're currently all protected. But hey, maybe we'll find one that is not protected. There's also the GCP Privilege Escalation Scanner. And the purpose of this is to scan for, yes, that's right, privilege escalation. So we're going to do an enumerate member on this, maybe a check for privacy. There's all kinds of commands that you can run with this one to try to escalate your privileges. And then GCP Bucket Brute. What do you think this one does? Yes, it helps you to brute force GCP buckets. So in this one, you can see we're running the command. So out of Python, and we're doing GCP bucket brute.py. And in this case, we're just running a test. But that's typically how the output looks. And then we can create backdoors. Backdoors are really, you know, don't tell anybody this, but in many of my early roles as a network and system administrator, did I tell you this already? But if I did, just keep it to yourself. But what I used to do is every time I got a job, once I got established in the job, I'd create at least one other account, sometimes 3 other enterprise accounts, just to make sure that if I lost access, I would have more accounts that I could, backtrace into. These days, you can't do that because admin accounts, administrators, enterprise administrators, they're all monitored, rightly so, knowing what I was able to do over the past years. But yeah, I used to do that, having my little backdoor available. You can create new IAM roles with gcloud IAM roles create. That's the command. You can assign new roles with gcloud project add IAM policy binding. So these are just nice little GCP CLI commands that you can run. But there are also apps that you can run. Another Goat app. Told you these were all around. So this one is the GCP Goat. And it too is vulnerable by design. You can run SSRFs on it. You can look for misconfigured buckets on it. You can practice lateral movement on it. And it's a nice little GitHub project, just like the rest of them, that you can use to make your skills better with hacking the GCP. objective number 7, container hacking. So we're going to focus, in this case, on Docker containers and some of the basic tools and techniques we can use to hack Docker containers. All right, so if you look at the main command that we're going to use for this, it's kubectl. So let's have a little bit of a deeper dive into kubectl. So if you look at here, we have kubectl, describe, get, logs, etc. What is kubectl? Well, it's a command line tool. And what we do is we use it to interact with Kubernetes clusters. We can use it to manage, gather information, inspect, manipulate, even deploy applications. And so there are a lot of commands. The first one you see here is kubectl get. And this is just really a list resource command. You could do kubectl get pods and list all the pods in the current namespace. You could do a kubectl get nodes and list all the nodes in the cluster. You could do kubectl get services and look at all the services, or maybe -o as an option to get more detailed information. Down here, the second one, kubectl describe. You can get just information about a resource. You could do kubectl describe pod and get detailed information about a pod. kubectl describe node and get information about a node. And then over here we have logs, but there are other ones, like for instance, kubectl create to create a resource file directly from a command or from one defined by YAML or JSON. kubectl apply to apply configuration, and many others. kubectl delete, scale, edit, rollout, logs, and a huge number of CTL commands. So kubectl commands. So when you look at the kubectl commands that we see listed here, they represent the core of Kubernetes commands that we would use anyway. But in this case, what we're using them to do, in this case, is to gather information. So we see some of these commands. There are a lot more that we could use. We use other commands to enumerate registries. This is as a Docker command, Docker login. Just like I was talking just basically barely about the list of kubectl commands, there is a giant list of Docker commands. And then if we want to pull information, we can get that using some of the curl commands, get tags, images in the registry, etc. And there are tools. One of the tools is Trivy. You want to detect vulnerabilities in packages, dependencies, etc. You can get that from Trivy. Another one is sysdig to find Kubernetes vulnerabilities. And then there's kubescan and kubeaudit, kubehunter, and many other commands out there. And then we have the ability to, for Docker, exploit remote API. So what we want to do is go get files from Docker. What we're trying to do is, in this case, get an image of Alpine Linux. So we do $docker-h report pull Alpine. So we can create a container, we can get files in the container, we can scan the internal network, all of these with basic commands. We can get credentials, again, basic Docker commands. These are all Docker commands. So it's not like I'm using a third-party tool all the time to get Docker commands. Most of the time, I'm just using Docker commands, not third-party tools. Then we also have container volumes. We can get information from there. Maybe find weaknesses in those volumes, maybe access master nodes, or maybe access a container, gaining access to it. Remember, we did a little bit of hacking of NFS before, and this comes into play also when we're hacking containers. There's also privilege escalation. So we are able to get to that Docker host, and we want to be able to make ourselves as privileged account as possible. These are some of the steps to create an Alpine Docker image. So it takes you through all the steps to create the image, and then we check for the image in the container. We run commands to create the container. We run commands to execute the container, and finally gain root. So this is a whole series of commands. Not going to go through each one of them, but these are a good representation of what we do for privilege escalation. And then we also have the idea of etcd. Let's take a look at some of these commands and talk about what etcd does. What is etcd? So like kubectl, it's a very central feature of Kubernetes. So etcd, what is it? It is a distributed, see right here it says key value storage. It's a distributed, it's a consistent key value store that's absolutely critical for a Kubernetes cluster. So it's going to be the primary data store for Kubernetes cluster, storing all the cluster data, current state of the cluster, configurations of the cluster, cluster metadata, service discovery details, API objects, and many other cluster-related information. So for some of the key features of etcd is nice, distributed, consistent distribution. Like we said, primary data store. It does service discovery. One of the cool things about it, doesn't say it on this slide here, but it has high availability, so you can deploy it in a clustered mode where the instances work together for high availability. It supports transport layer security, helps to safeguard sensitive information. So a lot of stuff. So if you look at the commands that you see on here, the first one you see is ps. If you ever see a ps command, all of you who know Linux know that we're looking at services, right? So we're also using this pipe command where we're taking the output of the PSEF and taking that output and grepping that output, which means we're going to search for a specific pattern, and that pattern for grep in this case is API server. So we're going to find anything that has to do with API server. We're going to find, locate that etcd server and all its related PKI information, public key infrastructure information. So now let's look at this one down here. This is a much longer command, and this is our etcdl API 3, et cetera, et cetera, et cetera. What are we doing? This command is, if you look at it piece by piece, which we're not going to do every piece of it, we're trying to extract secrets by accessing the etcd database directly. But this will only work if you have the appropriate credentials. So if I just kind of snuck in as a user, this won't work. But if I have appropriate credentials, whether I forged those credentials or whether I was able to obtain those credentials, this command would give me all that information. Objective number 8. You need to secure your cloud. Let's talk about some security. Again, I warn you that there are a lot of tables that have a lot of information in them. And what I want you to remember is some of the same things we talk about with other security and countermeasures applies here. Ubiquitous encryption, ubiquitous IAM, ubiquitous hardening are going to be the top 3 that are going to be in play here. And then using services and features of the various cloud vendors that will help you lock down your cloud. Let's start with a few security considerations for the cloud, right? So it needs to be tailor-made. Every vendor has different ways of doing it. One of the areas that I really appreciate is when you get into the vendor, they will warn you. They will give you instructions. They will help lead you through the most secure possible implementation if you follow. But be aware they're multi-tenant, meaning that something can happen with another cloud tenant that affects you. And you need to have disaster recovery. You don't want to have all of your eggs in the cloud. And it's kind of a weird analogy, but you know what I mean. And so you want to be able to recover if anything goes wrong. Also, continuous monitoring, looking at the QoS, making sure you've reviewed your SLAs with your management team, upper management team, lawyers. We also want to make sure that data stored in the cloud, we know exactly what that data is by using data integrity. It's not so difficult. Those tools are provided by the cloud provider. And cloud computing services, they should be fast, reliable, and provide a quick response. And normally they are. If they aren't, there might be something wrong. You need to discuss it with your cloud provider. Symmetric and asymmetric cryptographic algorithms must be implemented for optimum data security. Guess what? Your cloud provider gives you data about how to do that. Operational processes of cloud-based services should be engineered. You don't want to just do it haphazardly. Operated and integrated, that security has to be engineered right in there. And then load balancing. So we stripe the resources across multiple regions, multiple resources, load balancing, etc. And the cloud service provider should provide better resilience and enhanced protection from physical threats. I asked you this before, but have you ever had a chance to tour a data center? If you did, you'll notice it's much more difficult to get into than federal buildings, Fort Knox. Actually, I've never been to Fort Knox, so I'm not sure how hard it is to get there, but we use that as a analogy quite a lot, right? Maybe whatever the most secure installation that you can imagine. That's kind of how some of these data centers are. Multiple layers of security. They don't have moats, but yeah, maybe they will in the future. All right, so some tools that you can use to assess your cloud security. This one is pretty cool. It's called a Scout Suite. Multi-cloud security auditing gets you your security posture. You can use it to pull that information. It has a nice little CLI, and it has a GUI on top of that. Best practices, enforce data protection, backup, and retention. That's the most important one. You want to make sure everything's backed up, SLAs. We talked about that before. Also, check your cloud provider and see what kind of audits they do. This is just one, the AICPA SAS 18 Type 2 audit. That's just one of literally scores of audits that some of these vendors will do. Making sure that you don't have any cloud domains on a blacklist. You, again, along with the SLAs, check legal, making sure that your users know how to treat credentials, authorization, authentication, and accounting should be primary with what you're doing. Logging, data protection, encrypting data as it moves in and out of the cloud, analyzing that SLA comes back again, APIs. I mean, your cloud provider should be up 24/7, 365. I mean, hey, why not check to make sure they're up 30, 10, 400? I mean, go all the way. So either way, we have all these standards that each of the cloud providers, if you go into their descriptive pages, talk about that. We need to look at dependency change for APIs, registration and validation processes in the cloud. So quite a lot we need to look at. 2FA, MFA, wherever possible, and every traffic flow in the cloud. And so we have auditing that needs to be integrated into the cloud, especially when you're doing integrated multi-cloud environments. Security groups, talked about that in all of these as part of IAM. Instance awareness, the cloud-based kill chain model, right? It describes all the possibilities with fake cloud instances and command and control and so on. So have a look at the kill chain for the cloud. So there are many different vulnerabilities and solutions, from no certificate revocation to unauthorized HTTPS and exposed tokens and hard-coded credential paths. So when you have a chance, go through and look at each of these. There are quite a lot of them looking at serverless security solutions. And most of this stuff we've talked about to a certain extent, so I'm not going to do a deep dive into it. Container security, monitoring CVEs. We're going to be doing that anyway, I hope. Checking to make sure that none of the container data components or whatever appears in CVEs. And many others, configuring orchestrators to deploy sets of hosts separately based on sensitivity level. So quite a lot for that. Docker security gets a little bit deep into making sure that they're trusted, that we never expose the daemon socket. that sounds like something that you have to avoid in some video game. Never expose the daemon socket. But in reality, what is a socket? Remember, we talked about that before. It's an IP address and a port. And we don't want anybody to know that core service where it is located, right? And so there are a lot of other API, info, read-only. We want to make sure and protect Docker and Kubernetes. More tables of things we want to do. Again, look at this. Use KMS. KMS, that is ubiquitous IAM to enable secret data. What? Encryption using AES, CBC, or GCM. That is ubiquitous encryption. So a lot of these circle around that, adequately protecting files. Then we have serverless computing, best practices for serverless computing security. They are talking about some of the tools that you can use to scan serverless computing to make sure that you scan for vulnerabilities. One of the best ways to secure your cloud, to secure your workloads, to secure your local network is back to ZTI, so Zero Trust Networking. So if you've never dealt with Zero Trust, what it is it comes from, I think it was Donald Rumsfeld who made up the idea of trust but verify, right? This goes away from that into never trust, always verify. So we don't trust any connectivity from any resource, from any device, from any program, from any app, from any service, on any protocol, anywhere is untrusted. And so if the legacy or the gateway or the vendor or any of these attempts to communicate with any other component in the cloud or on the premise, it will have to be verified. And that means that if I, an attacker, somehow find my way into the control plane, I can't move anywhere. I can't do anything because my process is not trusted. So it really helps to stifle everything we've been teaching you. So ZTA, ZTN, these are ways to go zero trust. Another thing that is very helpful, because not everybody can go 100% zero trust, what you're going to have in between the organization and the cloud services is a CASB server. So CASB, Cloud Access Security Broker. They could be in the cloud, they can be on-premise, and what they're going to do is every communication, they're going to check for visibility. All right, someone else is using a mobile to get to the cloud. Data security. Somebody is using a laptop or a desktop or a server or something like that. Threat protection. So it stands in between. Does it slow down your access? A little bit, yeah. So that's why you need to have dedicated high-speed CASB. But it is another way to help very much secure all of the throughput between your organization and the cloud. Well, good job. You have made it through Module 19. And here in Module 19, we discussed some basic cloud hacking, basic cloud security. We talked about some cloud hacking apps and cloud security and CLI tools. We started with AWS, went through Azure and GCP, and then we ended up talking about some general security, lots and lots of tables that you can review in depth at your leisure, or you can discuss them with a team in the future when you're doing pen testing or other types of security for an organization. And you have your Kubernetes and Docker administrators, your cloud administrators. What we do is we circle back with them in our pen test report, and we make sure that they're following each one of these items to secure all cloud workloads. So we have some cloud exercises, and I want to warn you about something. You have to create an Azure AWS account, but we'll talk about that during the lab. And then we'll move into our last lab, which will be dealing with cryptography. We'll see you there.